Okay, a short textbook section, and I think this is going to just be two short videos. So again, read everything, watch the videos from the publisher, but I'm going to just briefly present the idea that functions can be and often are combined algebraically. And the sort of probably most classic, easiest to understand example of this, and the one the textbook gives as its example, is you have a company, and the company is selling something. It's selling widgets, and it's, of course, hoping to make a profit. So this company generates revenue when it sells widgets. So we have a revenue function. This revenue function has as its input the number of widgets sold. It has as its output the revenue generated. But it's not all roses. There are costs associated with this. I mean, the widgets you're selling have to be acquired somehow. They have to be stored somehow. Wherever you're storing them, you're paying rent, presumably, or you're paying for heating. If you're not just you, if you have employees, there are costs associated with having employees. So there's revenue, but there's also cost associated with this. And the input is the same. The input is how much you're selling, and the output now is the cost expended. So profit is the revenue minus the cost. If your revenue is bigger than the cost, this will be positive, and that's good. You're in the black. If the cost is bigger than the revenue, this will be negative, and that's bad. You're in the red. So, we can define a profit function. The input and output are what you'd expect them to be. The input is going to be the number of widgets sold. The output is going to be the profit generated. And now taking this statement and expressing it in function notation, P of X equals R of X minus C of X. So nothing here very shocking, I think. But you see, we're using an algebraic operation. We're using subtraction to define a new function from two old ones. So notationally, if we have two functions being subtracted from each other, here we're giving this a new name. We're calling it P of X. But we can just name, this function minus this function defines a new function. And if we want to, it's very standard to just name this new function. Well, what's the name of this function? This function is named R. This function is named C. R minus C of X, which if I can find it in here we go. You see, of course, there's nothing magical about subtraction. We can do the same thing with addition, with multiplication, and with division. This note here, this is something I see students do more in college algebra than in applied calculus, but it's just making the point that often when you have parentheses next to each other, that's shorthand for multiplication, right? Like if I have x minus 1, x plus 2, then I'm multiplying these quantities together. And the textbook is just emphasizing this looks a little like this, but this is not multiplication. This is a function. This is function notation. The other big way we can combine old functions into new ones is composition. And that's a different section of the textbook, or a different part of this section, I should say, and a different video.